This section will cover cloud feature identification. And this is important as spotters to be able to identify clouds, because once you can identify what type of clouds you're looking at, this will better help you understand the types of possible hazards that you can expect, which will help you in reporting to the Weather Service and also keeping you safe as spotters. Here is an overview of what we're going to be covering in the cloud identification and reporting section. We're going to cover several different types of clouds, beginning with shelf and roll clouds, including several examples, wall clouds, then we'll get into tornadoes versus funnel clouds, and finally scud or look-alike clouds. And these are clouds that can kind of trip you up, that look like some of the other cloud features but really are not. And we want to just point out a couple things to remember as we go through all of these different types of clouds. Always keep in mind what we call context. To help you identify a cloud, just ask yourself, does it make sense, the type of cloud you think you're seeing, based on what you see all around that cloud? Does it make sense given the context of what you're seeing? And always look for signs of rotation. That's one thing we want to be sure of, especially when we get to wall clouds, distinguishing between wall clouds and shelf clouds. Is there rotation occurring? And of course, we'll want to know if there is rotation. Is there evidence of rotation touching the ground? Is that circulation on the ground? Is there any debris observed at the surface? So you're going to want to look at your cloud feature and always make a connection down to the ground level to see if you can see any evidence of that rotation at the ground level. And then when we get talking about wall clouds, shelf clouds, and roll clouds, we'll want to identify, is the cloud sloping towards or away from the rain? And that'll be an important distinction to make between wall clouds versus shelf clouds. And the first cloud we're going to talk about is the shelf cloud. Here's an example of a shelf cloud. Just notice its horizontal shelf-like appearance on the leading edge of a thunderstorm. It expands the entire horizon. And when this feature passes overhead, that usually signals the approach of gusty winds, possible hail, and heavy rain. But gusty winds is definitely the main feature you want to look for as that shelf cloud passes over. And now, how a shelf cloud forms: typically you get cold and dense downdraft descends, and that occurs right next to warm, moist air, which is less dense, rising and condensing. And the fact that you have this updraft and downdraft right next to each other, it creates a rotor effect, and you get this shelf-like cloud at the leading edge of that downdraft. Now, since you have this updraft and downdraft right next to each other and creating that rotor effect, you will get a creation of horizontal rotation with the shelf clouds. And this is just rotation about a horizontal axis. And this is different than the rotation we see with funnel clouds and tornadoes, where the rotation is about a vertical axis, which we'll talk about a little later. So when this shelf cloud passes overhead, not only will you get that increase in the gusty winds, but if you look up, you may see some very turbulent motion and possibly some rotation about that horizontal axis. But it's important not to confuse this with a funnel cloud or tornado because of that horizontal rotation, not vertical. Now, at times, roll clouds can form when this intense horizontal rotation detaches from the parent storm. So the roll cloud races out ahead of the main storm. Now, but the roll cloud and shelf cloud form from the same processes. So when either one of these clouds passes overhead, gusty winds will be the likely main threat. And here is an example of a roll cloud formed when that intense horizontal rotation detaches from the parent storm. You can see in this feature that shelf-like cloud is detached from the parent storm, but again, when that passes over, expect gusty winds as the main threat. And here yet another example of a roll cloud. You can see it expands the whole horizon, much like the shelf cloud, formed from the same process as a shelf cloud. So again, gusty winds the main threat in this case also. Now, there are a couple of hints you can look for in identifying shelf clouds. In addition to the fact that they expand over the whole horizon and have that shelf-like appearance, the slope of the clouds is important. In this example, note your rain in the backdrop here, that very dark area indicating rain. But notice how your shelf cloud slopes away from the rain in the backdrop. So that's one thing you want to look at for shelf clouds, is that sloping away from the rain. We have another example showing that same concept can be seen on the following slide. your rain in the backdrop here in this dark blue area, and your shelf cloud again sloping away from the rain. And that's something you want to look for to identify shelf clouds. One thing to remember with shelf clouds is that you do not need to report shelf or roll clouds to the National Weather Service. But it's important to be able to identify these features because once they pass overhead, by knowing that gusty winds becomes the main threat with them, that's important for your safety, so you'll know to take cover should one of these features approach. You'll know that the winds are going to increase. But a couple of things to also be aware of with the shelf clouds. In this part of the country, we obviously have a lot of tree lines and a lot of buildings blocking views. Sometimes, like in this case shown here, there's a tree line blocking some of the view of this shelf cloud. And it can look like from this image that the shelf cloud is maybe touching the ground, but if we were to remove this tree line, you would see that it's not touching the ground. So just keep that in mind. Now also, your perspective is important. Shelf clouds can look different when viewed from the side or when they are directly above. In this case, we're really viewing a shelf cloud when it's almost overhead here, so it doesn't have that typical appearance that we've shown in the past several slides. And kind of a similar thing here. We're almost viewing this from the side or it's almost directly above us. So it may not look like a typical shelf cloud that we've shown. But again, remember, when this type of feature passes overhead, you likely would see that turbulent motion we talked about earlier. Now here's a time lapse of a shelf cloud from Delta, Ohio. And you can see as this feature approaches, you can start to see some of that horizontal rotation we've talked about. Not to be confused with what we're going to talk about later in funnel clouds and tornadoes. So this is kind of a source. Shelf clouds can be a source of false funnel cloud and tornado reports. So we just want to keep you aware of that turbulent motion and that horizontal rotation that we can see with these features. And the next type of cloud we're going to cover is a wall cloud. A wall cloud is a rotating lowering from a thunderstorm updraft base, indicating the presence of a strong updraft. And these wall clouds, as you can see an example of one in this picture here, these often precede a funnel cloud or a tornado. So that's why it's important to monitor these wall clouds, because they can be a precursor for a funnel cloud or a tornado. Here's an example of another wall cloud. Again, we're looking back to the west in this picture. One distinguishing factor between the wall cloud and the shelf cloud is, in the case of wall clouds, that cloud's going to slope back towards the rain, as opposed to the shelf clouds when the cloud sloped away from the rain. We can kind of put this in motion here to show how that downdraft rain-cooled air kind of gets ingested into that stronger updraft with the wall cloud. So that's why you kind of see that sloping back towards the rain. So that's one thing to keep in mind. We'll show another example here. Here we're kind of looking again, this is more looking back to the east. Similar thing though, your rain-cooled air and your rain is getting ingested into that wall cloud, so it slopes towards the rain. And so just keep in mind that with shelf clouds, the clouds sloped away from the rain, and that was more of a indication of a downdraft. But here in wall clouds, we're sloping towards the rain, more indication of an updraft and greater tornado potential. And just summarizing now the differences between a wall cloud and shelf cloud, just remember a shelf cloud is slanted away from the rain, a wall cloud towards the rain. With wall clouds, we do ask you call in rotating wall clouds because, as we indicated, they indicate strong updrafts and a potential of tornadoes. Again, no need to call in shelf clouds. They do indicate a downdraft and wind potential, but it's important to know that for your own safety if there is that increased wind threat with a shelf cloud or a roll cloud. If you have trouble distinguishing these wall clouds and shelf clouds in real time, we always want to remind people, if you have the ability to take a picture of these clouds and sending it to us on social media, we would appreciate that, because we can kind of pair your picture up with what we're looking at back at the Weather Service office to come up with a conclusion whether it's a shelf cloud or a wall cloud. And that brings us to funnel clouds and tornadoes. Now, as we talked about with shelf clouds and roll clouds, they can have rotation about a horizontal axis. But funnel clouds and tornadoes are violently rotating columns of air about a vertical axis. That's important to remember. It's also important to remember a tornado cloud may not always be visible. You may see that rotation aloft and not see that condensation funnel below it. But that's why we always stress, once you identify that rotation aloft to go directly below that cloud, look at the ground level for any evidence if that circulation is reaching the surface. Now, this may seem like common sense, but it's important to make it clear in terms of the terminology so we can communicate effectively. A tornado, in that case, the circulation is in contact with the ground. That's what makes it a tornado. Whereas in a funnel cloud, there's evidence of rotation, but that circulation and that rotation is not in contact with the ground. So just remember that when we communicate in terms of spotter reports of a funnel cloud versus a tornado. One thing you'll find with tornado and funnel clouds is the fact that these clouds have very smooth edges most often, and that's indicative of strong rotation. Here's another example of in this case, a tornado with very smooth edges to the cloud feature indicating strong rotation, and it does look like that circulation is in contact with the ground in this case. Here's another example where we see the smooth edges and the strong rotation. Difficult here to see because of this tree line whether we're dealing with a tornado or funnel cloud, so it's difficult to make a final determination in that case. In this example, we do have a much clearer view of the ground. No evidence of any debris being kicked up, but we have that smooth edges with this funnel cloud aloft here, and the fact that there's no debris being kicked up makes this a funnel cloud. And the same thing on the right here with this smooth edges to the cloud indicating strong rotation, but no evidence we can see of any debris being kicked up, and another example of a funnel cloud. And yet one more example here, very smooth edges indicating strong rotation, no debris being kicked up at the surface, and so we would make a determination of a funnel cloud. And sometimes it is difficult because of things such as a tree line or rain kind of obscuring your view to make a final decision whether you're seeing a funnel cloud or a tornado. In that case, just send us a picture or video and we can pair that up with data we're looking at back at the office to determine what we would conclude the cloud to be based on all the data. But one thing we would like to remind you, if you are reporting a tornado, please don't send that, for example, to our Webmaster account. Since that's something we would want to know about right away, we may only check that Webmaster once every half hour or so. So a phone call is probably the best way to handle a tornado report. Now we're going to show you an example of a tornado which occurred in November of 2017 in Jay County. And this is an example of a tornado which formed during that secondary peak that we've talked about in the fall of a tornado activity. And just notice in this clip, you want to be looking below the cloud level for evidence of debris, and you will see that eventually with this tornado, which allowed these storm spotters to finally make that conclusion of a tornado.
Just a little bit, please. All right, this is good. I can hear it on the ground. Okay, go ahead and pull forward some. I don't want this thing overtaking us too much.
And one of the last clouds we're going to cover is what's called Scud cloud, which just stands for stratocumulus under deck. Scud clouds are ragged versus the smooth clouds we saw with tornado and funnel clouds. Scud clouds are harmless, they're ragged looking as we mentioned, they do not rotate, they can be turbulent. A lot of times you can see these clouds moving up and down fairly quickly, but just remember that they are not associated with any persistent rotation and are harmless. And it's important to be able to identify these because we see these quite a bit in this part of the country. So we want to make sure we can avoid misreporting these as something else. And we do have several examples of Scud cloud. As I mentioned, these are very common in our area. Just note in this example the very ragged cloud edges here. Again, this is not indicating rotation in this case. And this would be a harmless cloud. Same thing in this cloud, very ragged edges to the cloud. One thing that is a little concerning to some spotters if they see this is just how close to the ground this cloud is. But if you remember the idea about looking for persistent rotation, you don't see that here. Very ragged feature. not really connected to any wall cloud or organized lowering base of the cloud, that would steer you toward the harmless scud cloud in this case. And another example here of ragged clouds, again, not attached to any organized wall cloud, just off on its own kind of. And if we had a loop of this, you would see that it's not rotating. Could be some up and down motions with the clouds, but no indication of any organized rotation. So again, a harmless scud cloud. And here's just a video clip example of a scud cloud, really showing here the lack of a coherent, persistent rotation. Again, that context we mentioned, is it attached to any lowering of a rain-free base? Is there any wall cloud that forms? There's really not in this case. It doesn't really have much structure. Again, no evidence of any debris being kicked up at the surface. There's no rotation. So again, a good example of scud. One other thing that can be misidentified as a tornado in this part of the country, similar to a scud cloud, are rain and hail shafts. These are often mistaken for tornadoes, but just keep in mind, what part of the storm are you looking at? Is there any rotation or debris? It's back to that context that we talked about. Does it make sense that you're looking at a funnel cloud or tornado based on the picture of the clouds and what you see around that area? In this case, you don't really see any structure in this picture of any lowering of a wall cloud development. This is just a rain shaft forming. And another example here, again, there's not any development of a wall cloud. It's just a very ominous looking feature if you're far away from it. But this is actually an example of another rain shaft. Again, if you're out there viewing this feature, you look for any persistent rotation. Just keep your eye on it for a few minutes to see if you see any evidence of rotation. In this case, with this rain shaft, you would not see that rotation. And here is another example of something that looks ominous, but when you take into account all the factors we talked about, you can identify this as a rain shaft. Again, we don't have that debris kicked up at the surface, don't have persistent rotation. Again, this would be more of a rain shaft feature. Now to wrap up the cloud identification section, we're going to pull everything we've learned from this section into the next several examples to identify each of these types of clouds. In this example, we're going to go through one of our checklist items. Is this cloud sloping towards or away from the rain? That's one of the things we use to identify shelf versus wall cloud. In this case, the cloud is sloping away from the rain, and so that would make this a shelf cloud. So in this example, we'll ask the same question. Is the cloud sloping towards or away from the rain? And just by looking at this, it becomes pretty clear in this case that that cloud is sloping back towards the rain there on the right side of the picture. And so, taking that into account, that the cloud sloping towards the rain and that rain-cooled downdraft, what cloud would that be? If we go back to what we discussed earlier in this section, sloping towards the rain would indicate wall cloud. And again, wall cloud just means the updraft is going to be more prevalent, and there could be some potential of a funnel cloud or a tornado developing. For this example, just focus on the cloud circled in yellow. First, we're going to ask, is it rapidly rotating on a vertical axis? It would be easier if we did see a video clip here, but I'm going to assume here that there's no rapid rotation, so just remember that. Is it smooth or ragged? It definitely has that more ragged appearance. So we're going to check ragged for that. Is it touching the ground? Is there debris at the surface? Well, it is hard to tell at this point because of the tree line, but we are going to assume at this point that it's not touching the ground, does not appear to be, and there's no evidence of debris at the surface, even though we are partly blocked by the tree line. So we'll put X's for both of those. So given that above information, we would conclude that this is a lookalike cloud, or more specifically, scud cloud. This example is a little more difficult here. Is it rapidly rotating on a vertical axis? That part is pretty easy. It does look smooth, so we will check smooth for that. Is it touching the ground? That's what's hard to see in this particular example, especially since we don't have a video clip to see things in motion. But if we blow this up a little bit, we can see evidence of that debris being kicked up at the surface. So knowing all that, the smooth cloud indicating rapid rotation, evidence of rotation at the surface, What would we call that? That would be a tornado. For this example, just focus on the cloud outlined in the black lines there. We'll go back to our original question, is this cloud sloping towards or away from the rain? If you can imagine here, the rain in the backdrop, almost indications of a rain shaft that we talked about earlier, not to be mistaken for a tornado, but just a rain shaft. So you can see here from this picture, the cloud is sloping away from the rain. And the fact that we know the cloud is sloping away from the rain makes this more of the shelf cloud type, and again a concern for gusty winds as opposed to a tornado potential. Again, not much of a tornado potential in this case, more of a gusty wind potential. And here's our last example, which may be a little more difficult, but just remember the ideas of context we talked about when coming up with the decision on what type of cloud this is. We'll just take a few seconds here and let you come up in your own mind what type of cloud you think we're looking at. Okay, here, this is an example of a look-alike, particularly a rain shaft. We don't really see that connection to an organized lowering of the cloud base or a wall cloud. There's really no evidence of rotation if we had a video clip of this, no debris being kicked up at the surface. So taking all that into consideration, this is one of those look-alike clouds, rain shafts, that can trip you up maybe into falsely reporting a tornado.